So we are on 2B.2, estimating and solving exponential equations. Okay. Estimating and logs with calculator and Desmos. So we're going to be using calculator or Desmos, whichever one you prefer. That's what we'll be utilizing for today. Okay. So on your assignment, 2B.1, you had a problem that you couldn't solve, right? You couldn't solve it because you couldn't use any of your basic elementary operations, addition, subtraction, multiplication, or square root, right? We couldn't use any of those. Okay. However, there is an option because those did not work for number 6. Number 6 is called an exponential equation. Okay. It's an exponential equation because your unknown is the power. Okay. So we're going to first start off with the estimating method of solving exponentials, and then we're going to talk about the calculation method, the actual method to estimate. Okay. So starting off with estimating, the first thing you want to do is you're going to find two values of x, the power that will create a range for the value. So you're trying to figure out if x is this, where does my solution fall in between? Okay. In order to estimate, you have to make sure the exponential is by itself. So we got to make sure that the exponential is isolated. So do y'all remember this problem? Yeah. Yes. Number 6 on your assignment, the bonus. Okay. This was the challenge. See, how could you figure this out? And what is this saying? So in words, this is saying 2. Why is it not letting me write? Oh, okay. There it is. All right. So we're going to erase that really quick. So we're going to write 2 raised to an unknown power. Does that make sense? Equals 9. Okay. You should have been able to at least write this, right? The sentence, the math sentence, explaining what this 2 raised to an unknown number, unknown power equals 9. Okay. What this is saying when you're solving this and undoing it is you have to figure out what that power is. When I'm reading this using inverse operations, there's nothing in here that helps you work backwards, right? There's nothing, oh, minus, I'm going to add, or divide, oh, I'm going to multiply. There's no lead to inverse because this is not a problem you can solve with inverse. The first method of solving this problem is by use of a table and approximating. So when we're using a table, we have our x and our y. Our y are our output. What would it equal? In this case, y equals 2 to whatever power we're saying. Okay, so we're going to start with values. So if I have x equals 0, that means 2 to the 0. Anyone remembers what anything to the 0 power is? 0. 1. Anything to the 0 power is 1. Okay. If I let x equal 1, that's 2 to the 1. What is 2 to the 1 equal? 2. If I let x equals 2, that's 2 to the 2, which is 4. If I let x equals 2 to the 3, what does that give me? Oh, sorry. X equals 3. I wrote it in the wrong box. You see nothing. And this would be 2 to the 3, which is 8. So far, have I gotten to 9 yet? No. So logically, it's telling me my next number, right? Logically, whatever that next x, which would be 4, and I didn't leave myself a box for that. But if I had 2 to the 4, what is that? 16. So this means that x is in between, right? X has to be greater than 3, but less than 4. And that would be the value. That's how much I can approximate. This would be our answer, our approximate answer, not our exact. This would be our approximate. So our x is between 3 and 4. Notice that I don't use equal to because it's not equal to 3 and it's not equal to 4. It can't be. It's somewhere in the middle. Okay. How do you feel about approximating? Approximating is useful if you are taking a multiple choice test, right? And you have 4 options. When you're looking at those 4 options, if they don't, you're looking for the one that falls in between this range. Does that make sense? If it doesn't, then that's not my answer. It can't be it. Cross it out. All right. So you're going to try at your table with a partner or a nearby partner if your table is empty because you're lonely. Your partner. Here you go. You have 3 to the x equals 26. Find the approximate value of x. All right. So, we are going to start off. Is there any point in me starting at 0? No. So, I'm going to start with 1. 3 to the 1 is obviously 3. Start at 2. 3 to the 2 is 9. 3. So, do I need to go any further? No. So, my approximate x value is between 2 and 3. Yay, we can do it. We can approximate. Cool. All right. Next. Now, the key thing we told you that you have to make sure before you start approximating, you have to make sure that your exponent is by itself. In this case, our exponent is not by itself, right? So what do I need to do to get it by itself? -1. So I subtract 1 from both sides. So now we're actually working with 2 to the x equals 29. Okay. I'm going to just go ahead and jump to x is 3. Is that cool? Okay. X is 3. That's 2 to the 3rd, which is 8. Then I have 2 to the 4th, which is 16. Then I have 2 to the 5th, which is 32. And therefore, x is what? Between 4 and 5. Greater than 4 and less than 5. Yes. This one is small. What if it had been a larger number? What if it had been a larger number? You wouldn't, yeah, that's why we practice isolating. All right, so what is the inverse operation of exponentiating? What if, like, you want the exact or closer to an exact answer? Well, it's called taking a logarithm, okay, or a log of the function. So to actually mathematically solve this and get the value, we're actually going to take what's called the log, okay? You take the log of both sides of that base. So whatever the base is of your exponent, you're going to take the log of that base, okay? What you do to one side, you have to do to the other. What this does is it cancels out the exponent and turns the exponent into a regular variable. So your exact value, so this is my exact value, is log base 2 of 9. My approximate value is 3.17, and we said that it would be between 3 and 4. Were we correct? Yes. Okay. Are we ready to try this? So at this point, we need to get out our handy dandy calculators. You can use decimals. I'm going to go over the steps for TI-84s. So step 1 is you want to make sure the exponential term / factor is by itself. And you do so by adding or subtracting, then multiplying and dividing to get it free, okay? Next, you're going to take the log of the same base of the exponential to both sides. We're going to, the log will undo the exponential. So set the power free is what we're doing. We're going to set the power free, okay? Input the log into the calculator. If you're using a handheld calculator to access it, you press alpha window and 5. So if you're using a handheld, it's alpha window 5. If you are using Desmos, you literally are going to type log and then shifts underscore so that you can put the power, okay? So if you're on Desmos, this step is a little different. You type the word log and you're going to press shift and the dash underscore button, whatever that is, that guy. And that'll allow you to put the power, put the base. Y'all know what that button, what I'm talking about? When I draw it like that. Okay, cool. And then you're going to press enter and approximate. I will model both, and then you will decide from there. Got it? Okay. Now, there is, before calculators were so sophisticated, there is what we call the change of base formula. The change of base formula is how you have to solve if you only had a standard scientific calculator. So if you had a log base of any number, and then the argument. To find the exact value, you would have to write log of the argument divided by log of the base. Log of the argument divided by log of the base. And that would give you your exact answer. So for example, we have log base 5 of 7. So if I wanted to find the exact answer, it will be log 7 over log 5. That's my exact answer, okay? And then to find the approximate, I would put into like my phone calculator or my standard handheld basic scientific, and it will give me this. But because now our calculators are programmed where we can put whatever base we want, this is not as used as often, okay? Yeah, but I'm still supposed to teach it to you, so here you see it, and yeah. You either can use log or natural log. Either way, still going to get the job done. All right, here we go. So we have 3 to the x equals 20 to the 26. So 3 to the x equals 26. And we said that this value should be between what? We just did it. 2 and 3. So we know that we're looking for a value between 2 and 3. So I'm supposed to write it in log form first. So if we have 3 to the x equals 26, we're going to take the log of the base of both sides. So what this becomes is it becomes log base 3 of 3 to the x. What this does is it sets the power free. So x is now free. But what I did to one side, I have to do to the other. So we're going to have to do log base 3 of 26. This is my exact answer. This is the exact. Okay. Now, if you had to write this in log change base form, it's log of your argument over log of your base, and your base is 3. Either one of these inputs is going to lead to an approximate value, and we're going to look at that approximate value now. So I'm going to model it with the handheld. Good old Sylvie. Hey, girl, hey. And I'm going to clear second plus 7, 1, 2, because I've been doing trig in there. Okay, so it said we're going to press alpha window, and we're going to press 5 for log base. Do you see that? And now I'm going to type it in, because y'all are so spoiled, but back in my day, we had to use change of hearts. Okay, and we get our approximate value. Is that between 2 and 3? Yes, we knew we were right. Okay, just to show you what this means, if I just hit log and type in log 26 divided by log of 3, do I still get that same answer? Yes. Okay, so if you, for whatever reason, forget, oh no, how do I get the base? That's what this is, your saving grace. Okay. Either way, so we have 2, and we're going to round to the nearest 3 decimal places. 966. 966,000. 10, yeah, thousand. Was that terrible? Yeah. No, it was not. And you know it. It was not. All right. Let's do our next one. So we did this one, and we said that x is between what? What did we say it was between? We said x should be between 4 and 5, right? So that's where x should be. We have to isolate our exponential. Isolate our exponential, we subtracted 1, and that left us with 2 to the x equals 29. Okay, now we're going to take the log of both sides. All right, so our log base has to be the same base of our exponent. We're going to do log base 2. And what does that do to our power? Sets it free. So now x equals, and what I did to one side I have to do to the other. Log base 2 of 29. Okay, this time I'm going to model it in Desmos. So again, you can leave it like this, or you can take the log of the argument divided by the log of the base. Let's say you were doing your homework on your phone. That's how you would do it on your phone. You can pull out your phone calculator, type in log 29 divided by log 2, and you're still going to get the answer without having to have a full scientific calculator. Okay? All right, so let's go look at the Desmos. There it is. And I'm going to delete. So I'm literally just going to type in LOG, not capitalized though. Log. Shift underscore button. And it was log 2. And arrow over to typing your argument. And what's my argument? 29. And what does it tell me? There we go. Other thing I could have just done is typed in log, parenthesis, 29 divided by log, parenthesis, 2. And do I get the same thing? Yes. Okay. So our answer is 4 and 858 thousandths. 4 and 858 thousandths. So X is approximately 4 and 858 thousandths.
Okay, so it has to be to the third?
Third decimal.
Correct.
Thousandths. Yes. Okay. How are we feeling? Easy peasy? It's not bad. You just want to complain. That's what it is. You just want to complain. All right, here you go. We're going to do a harder one. This is going to be the hardest to get. And if we can do this one, we can do them all. Got it? Yes? All right. So looking here, we have 3 to the x plus 1 minus 2 equals 100. Okay? Our goal here is that we have to get our exponent by itself. So the first thing we're going to do is what? Plus 2. Once we plus 2, we're left with 3 to the x plus 1 equals 102. Okay, now our exponent is by itself, so we're going to do what with the exponent? We're going to log it. We're going to take the log, and the log has to be the same base as your exponent. So we're going to take the log base 3 of both sides. Are you with me? So this is going to free our power. So our power is free. And what I do to one side, I have to do to the other. The only thing that makes this one is different is that x is not by itself. So there's an extra step that I have to do to get x by itself. What do I need to do to get x by itself? Minus 1. So we're going to subtract 1, subtract 1. So our exact value is x equals log base 3 of 102 minus 1. That's our exact. Okay. We're going to plug it in and find our approximate. So plug it in to find your approximate using your calculator of choice. So I'm going to do alpha window 5, and I have base 3, 102 minus 1. You got what?
Oh,
like what? How'd you get a 4? It's on the outside. The minus is on the outside. That was a second step, right? Okay. If it helps you, protect your argument, and that helps you remember that that is separate. Okay. So we now have 3, and that's going to be 2, 1, 0.
Yeah.
All right. How we feel? Was it terrible? It was not. Okay. So your classwork. You have 8 problems. Practicing. Taking the log. Got it? All right. Go be great.